Hello, in this problem we're going to go over problems from Module 4, Average Rate of Change. Remember, it is important for us to try this problem actively. So if you have not tried these problems already, pause the video before each problem, right before I go over each problem. So for number 1, if you have not tried yet, pause the video, read the problem, try on your own, then unpause to see if your work matches my work. So number 1, when running a marathon, you heard the timer call out 12 minutes as you pass the second mile marker. As you passed mile marker 5, you heard timer call out 33 minutes. What was your average speed from mile 2 to mile 5? In order to find average speed, we need to find change in distance, delta distance, over delta time. So average rate of change is relating two quantities. We want to find relations between two changing quantities, two covariant quantities, and how they're related in average between specific interval. So change in distance is 5 mile minus 2 mile, and time is 33 minutes minus 12 minutes. So it is important to put the numbers in correct position. 5 mile give us 33 minutes. That's why 5 and 33 are first. And 2 mile give us 12 minutes. So then if we subtract these, we get 3 miles over 21 minutes. And we can simplify to 1 mile over 7 minutes. That means that in order to cover 1 mile, in average it took 7 minutes. Or 7 minutes gave us an average of 1 mile distance covered. And we can also write this as 1 over 7 mile per minute. Sometimes instead of per, we also write this slash as well. So average speed between mile 2 and mile 5 is 1/7 mile per minute. So in average, I traveled 1/7 of a mile each minute. Remember, finding average rate of change is different from finding average of a single quantity. In order to find, for example, average height in our class, we just need to collect all the height data from all the students and add them and divide by how many we added. But in average rate of change, we're averaging rate of change. And rate of change itself deals with two different quantities. Change in two different quantities and how those two quantities are related. That's why when we find average rate of change, it is different from just averaging a single quantity such as average height, average score, average age, all those things. Second problem. Again, pause the video, try on your own, and come back when you complete it. So compute the average rate of change of this function 2x plus 1 from x equals 3 to x plus h. So this is an interval. Sometimes it could be written as like this as well. So in order to find average rate of change, again, practice writing function notation with delta f over delta x, change in output quantity over change in input quantity. So delta f is f of 3 plus h minus f of 3 divided by 3 plus h minus 3. So for numerator, we plug 3 plus h into this function. We get 2 of 3 plus h plus 1. This entire thing is f of 3 plus h minus, now plug 3 in to this function. 2 times 3 plus 1. And denominator, we get 3 minus 3 give us just h. So let's simplify furthermore. So let's distribute 2 here. We'll get 6 plus 2h plus 1 minus this right here is 7. 6 plus 1 is 7. Divide by h. Then collect like term. 6 plus 1 gives us 7. 7 minus 7 gives us 0. So we're left with 2h over h, which is 2. So average rate of change of this function is 2 unit per unit. So unit of output quantity over unit of input quantity. So let's just quickly talk about how to interpret this in general. So delta f over delta x equals 2. So what we do is we can write this as delta f equals 2 times delta x. This means that change in function is 2 times as large as change in input. Okay. So as we can see, these two quantities are changing. So if this is changing, this is changing. Now how are these changes related to each other in average? It's 2 times. So if delta f is 2 times as large as delta x. And this function is actually a linear function. This is a straight line, right? So let me do a quick graph. Plus 1 is y-intercept. Slope is 2. So here is the graph. So you can also take from a toolkit function, right? Multiply by 2 and add 1. So this is a linear line. So slope of this line is 2. So this function only has constant rate of change. And therefore, the constant rate of change represents average rate of change of any two interval in this specific function. So let's look at number 3. Again, pause the video, try on your own. Then when you're done, unpause and see if your work matches my work. So delta f, change in f. So we're plugging these two values. F of 4 minus f of 1 divided by 4 minus 1. So we just plug the values in. So I get 4 squared minus 3 times 4 plus 2 minus 1 squared minus 3 times 1 plus 2 divided by 3. So let's simplify. 16 minus 12 plus 2 minus 1 minus 3 plus 2 over 3. So this is 4. So 4 plus 2 gives us 6. This gives us negative 2 plus 2 gives us 0 over 3. So answer is 2. So average rate of change of this function between this interval, not in general, just specific this input quantities interval, the average rate of change of this function is 2. Okay, number 4. So number 4, again, pause the video, try on your own. So it's a multiple choice. With the function fg and h graph as separate axes below. Let a of f, a of g, a of h respectively represent average rate of change of each function over the particular closed interval displayed on the graph. So all these are closed interval. These functions not arrow, so those are all closed interval. So which of the following is true? So essentially you're comparing average rate of change between these 2 points for all three functions. And to compare which one has the biggest average rate of change, or are they same? Okay, so pause the video, try on your own. And when you're done, come back and I'll go over it. Okay, so again, we want to stick to just main idea. We always want to focus on main concept. And the average rate of change is delta. So let's do one at a time. Average rate of change of function f, a of f is delta f over delta x. So here in this case, endpoints are for this function is at 2, between 2 and 8. Okay. So delta x, how much has changed here? This distance is 6, but let me just write it. 8 minus 2. And what's in the numerator? Is a corresponding output value, which is 8 minus 5. So 8 minus 5. So average rate of change of the first graph, f, is 3 over 6, which is 1/2. So let me write it here. Average rate of change of function, this one is 1/2 unit per unit, right? Output quantity unit per input quantity unit. So then let's look at this one. So again, let me actually draw it real quick. What we just found is here's change in x, change in f, and we divide this, which is actually finding same thing as finding slope of this line right here, this linear function. Because as you saw in the main concept video, average rate of change between 2 points of a nonlinear graph is equal to constant rate of change of a linear graph between the same 2 points. So half is also slope of this line right here. And this line is also called secant line. So then let's find a of g, which is delta g over delta x. In this case, we have this point and this point right here, 8. So we're finding this distance, which is 8 minus 1. So you can think as we're finding this distance, delta x, and finding y, delta g, which is 5 minus 2. So again, we're finding slope of this because delta g divided by delta x is finding slope of this, right? So we get 3 over 7. So a of g equals 3 over 7. Okay, which is a little less than half. Because were to be exact half, it should be 3.5 over 7, right? So it's a little less than half. So we just found slope of this point right here. Secant line. So let's look at this one. Same idea, a of h is delta h over delta x. Here, change in x is 9 minus 2. 9 minus 2. On the numerator, this delta x. change in delta G, oops, sorry, H in this case, right? H is 7 minus 3, which is 4 over 8, which is what? Oops, not 4 over 8, sorry, 7 over 9 minus 2 is 7, 4 over 7. So average rate of change between these 2 points for function graph G is 4 over 7. So we just 4 over 7 is also slope of this line, which represents average rate of change between 2 points. Okay. So we're comparing essentially these 3 fractions. Which one is biggest? 4 over 7 is the biggest, right? So A of G, A of G is biggest because 4 over 7 is a little bigger than half. And A of F is second because half. And smallest is, oh man, I'll keep doing this. My bad. This is H here, right? This is H. But this is actually, I just mess up the alphabet. A of H, which is 4 over 7 is greater than 1 over half. And 1 over half is greater than 3 over 7. So this is the answer. And which one is that? D. D is the correct answer. Okay. So just looking at the graph, if we only compare the slopes look very similar, which is why we will need to stick to the main idea, the definition of average rate of change, which is change in output quantity over change in input quantity, like as we wrote here. Okay. Because average rate of change is comparing two covariant quantities. It is just more than a slope in terms of interpretation. Although slope is just one way to think about it. So number 5. Again, I'm going to read the problem, then try on your own. Using the graph of f given below, determine a single numerical value. So this has multiple answers. Well, answer could be different between yours and mine. But as long as it's consistent in terms of idea, it's fine. Determine a single numerical value for a constant a, so number a, pick a number essentially, that makes the following inequality true. So essentially this is asking find a such that this statement is true. Okay. So let me just zoom in here for a second. I'll give you, pause the video, try on your own, and when you're done, come back, okay? So for this, it is important to remember what this represents. This represents average rate of change. Okay, average rate of change between A and A plus 0.5. So let me write it here. This represents, I'm just going to write A ROC of function f, let's call it f of x, yeah, f of x, between a and a plus 0.5, right? So we need to essentially want to pick a point where average rate of change between 2 points, and those 2 points are only have a difference of 0.5. That's why h here. Remember, in difference quotient, the denominator is h. And h represents change in input quantity, which is delta x. Delta x is 0.5. That means the distance between 2 points in 2 interval here is 0.5. So find the point that where average rate of change is greater than -1, but less than 0. Okay. So let's talk about what does -1 bigger than -1 mean? That means the slope or the average rate of change is greater than -1. So it could be -half. It could be also half, as long as it's less than 0. Right? So it actually cannot be half because half will be bigger than 0, right? So first we have to think about what is it. Pick a number. Pick a number that's between -1 and 0. So I'm going to pick -half. So now in this graph, we need to pick 2 points that are such that if I draw a straight line, also known as secant line, if I draw the secant line between those 2 points, slope of the secant line will give me -half as a slope. Okay, so let's write -half like this. And this will represent, this essentially will be change in f over change in x. Okay. This is slope. But we want to pick a point. So slope is -half. That means that slope negative means it will be slanted this way, like this or this. Or it could be do this. Okay. So we need to pick 2 points such that slope in those 2 points will be -half. Okay. So let's see. Again, we can try and error. So let me just pick one and see if it works. So maybe I pick, since the distance between these 2 points are 0.5. Let's see what will happen if I pick 2 and 2.5, for example. So let me just try one. Let's try a equals 2 and see if it works. If a is 2, a plus 0.5 is 2.5 is right here. This. Then if I draw a straight line between these two, is slope -0.5. Okay. So let me draw more precisely. So here is 2 and 2.5 is right here. Yeah, slope between these two. Okay. It's not, it doesn't look like at least -half, right? Because in order to be -half, change in y direction when it's 1. So change in y or change in f should be half size of change in x. So maybe this will not work. Okay. So let's try another point. Maybe let's try 2.5. So now for second try, we're going to try a is 2.5. Then it will be between 2.5 and 3. So 2.5 will be here, and 3 is right here. So let me draw a straight line between those two, like this. Let me try again. Okay. Again, it's somewhat of a sketch since the graph is not so perfect along with the points. But so here, if I want to find slope of this, Again, we're focusing on change in f, how much it has changed in order to get this change and this one. But since it's a straight line, the proportion is same. So I can essentially find the change in y, or change in f over change in x here as well, since it's a straight line. The proportion stays the same everywhere. So this one will work because here it seems like this is go down -1 and go right to 2, which give us slope of -half. So a equals, let me write a equals 2.5 can be an answer. Okay. Again, depends on how you draw a straight line. It might be you might be able to make it work with even what I did, 2 and 2.5. Okay. But the main idea of this problem is when you look at this expression right here and be able to interpret this as average rate of change between 2 points, A and A plus 0.5. Okay. Okay. Number 6. Find the average rate of change of this function from x to x plus h. Again, pause the video, try on your own. When you're done, come back. Okay. So, we're changing f over changing x represents average rate of change. So here we have f of x plus h. So there's 2 points. One is x plus h, one is f of x. Divide by x plus h minus x. Then denominator we can simplify really quick. Just to h. And this is what's known as difference quotient. So difference quotient expresses average rate of change in general, not in specific 2 points, just any 2 points, x and x plus h. Those are 2 intervals, not specific numerical values, but in general. So we need to be able to simplify this all the way down when we find difference quotient. So here's the tip. If you're not so comfortable writing right away, just write one step at a time. Write x plus h down first using this function. So then I get x plus h square minus x plus h plus 4. Let's simplify. X plus h square is same thing as x plus h times x plus h minus x plus h plus 4. Then we have to distribute here like these. Then we get simplify, we get x squared plus 2xh plus h squared minus x plus h plus 4. So this entire expression represents f of x plus h. So let me maybe underline red. This is this right here. And f of x, just write it one more time, which is just x squared minus x plus 4. So let's combine all these. Right, again, I also went over problem like these on main lesson video. Okay. So let's combine the entire thing to difference quotient. So first part, I'm going to put parentheses, copy this one down right here. X squared plus 2xh plus h squared minus x plus h plus 4. Oop, I made a mistake. I forgot to distribute negative sign here. Oops. So here, when I simplify this, I have to distribute negative sign. Right. When you want to get rid of parentheses, we have to distribute negative sign. So this right here is x minus h plus 4. So this right here is f of x plus h. Simplified. And I'm going to write f of x here, since we're going to subtract these two together, minus, make sure to put parentheses, x squared minus x plus 4 divided by h. So next line, we'll simplify by distributing negative sign. So copy everything down again. Negative x squared plus x minus 4 over h. Don't forget the h. Now we're going to just collect like terms, and some of them will cancel out. X squared cancels out with x squared. Negative x cancels out with positive x. Positive 4 cancels out with negative 4. So what we have left on the numerator is 2xh plus h squared minus h over h. And we can simplify this since h is the common denominator, or we can also factor the numerator. Either one's fine. So 2xh over h plus h squared over h minus h over h. Since h is common denominator, we can break down to 3 different fractions. Then we have 2x plus h minus 1. So this represents average rate of change of this function x squared plus minus x plus 4 between 2 points x and x plus h. So this is very helpful because if I want to find average rate of change between, for example, 2 and 6, then x will be 2 and h will be 4. So if I want to find, for example, between 2 and 6, this is x and this is x plus 4, right? X plus 4. So 4 will be h, change in x quantity, input quantity. So then I plug 2 and 4 here to find average change between 2 points. Okay, so you need to be able to simplify all the way down to get correct answer, the correct expression right here. So make sure you do practice, especially in homework as well. There are several problems simplifying difference quotient. So let's look at the last problem. Same idea. Pause the video and find the essentially difference quotient of this function. So pause the video, try on your own. When you're done, come back. Delta f over delta x. F of x plus h minus f of x. So here I'm just going to write h in the bottom because x's will cancel out again anyway. So again, h represents change in x, delta x. Okay, so keep that in mind. So you might also see this, because delta x and h are the same thing, we can also write it like this as well. Just another way to think about it. Actually, this is a more precise way to think about it. But a lot of homework and textbook just uses h. Maybe because it's less thing to write, you don't have to draw the triangle delta sign. But this is the same meaning. This is more precise because this signifies that we're changing how much x changes. Okay. It's co-varying. 2 quantities are changing. Okay. So, again, same idea. Unless you're used to it, I suggest you do one at a time. Express this one at a time first. So f of x plus h, simplify that first. Negative 2 over x plus h. And f of x is just negative 2 over x. So let's combine to this expression right here. Then we'll get negative 2 over x plus h minus, put parentheses, negative 2 over x divided by h. Okay. So let's simplify. Let me go to the right actually. So negative 2 over x plus h. Negative gives us positive 2 over x over h. So let me do this. So I'm going to write here negative 2 over x plus h. Now here on this, we need to have a common denominator to combine these two functions. So for first fraction, I'm going to multiply x over x. And x over x is just 1. So we're not changing the quantity, we're only changing how it looks. Times, for this one, I'm going to multiply x plus h over x plus h. So again, this is also multiplying 1. We do this so that top two fractions can have common denominator. So then, you have negative 2x over x times x plus h plus 2 times x plus h over x times x plus h over h. Now remember, this is a common denominator. Since it's common, we can just write it once. So negative 2x plus 2x plus h divided by common denominator of x times x plus h, entire thing over h. So let's distribute 2 here. We get negative 2x plus 2x plus h over x times x plus h, entire thing over h. Collect like term, these two cancel out. What I've left with is h over x times x plus h entire thing over h. Okay. And then write it here. We're doing h over x plus h divided by h. Dividing by h, you can think as we're dividing by h over 1. We can think the same thing as multiplying by reciprocal, 1 over h. Then it simplifies to 1 over x times x plus h. Okay, oops. Okay. Oh, I actually did make a mistake here. Forgot to write something. So here, we distribute 2 here, right? So this should be 2h here. You see that I wrote it here, but I forgot to write 2 here. 2h. So this is actually 2h. So cancels out, so we actually have 2 on the numerator. Yeah, I thought something was odd. So this is the final answer. Okay. So a lot of algebra, but it begins with difference quotient. So you need to be comfortable with plugging in x plus h, plugging in x. Okay. So again, practice this problem on your own. And come to office hours if you need help.